Okay, in this example, we're talking about the sampling distribution of the mean. Okay, it's just a brief introduction, and here's some notation. Mu sub x bar is equal to the original mean, the original mean of the original data. And the notation is mu with a subscript of x bar. And the standard deviation of the sampling distribution of the mean is denoted by sigma with a subscript of x bar. Remember, x bar is the symbol for sample mean. Okay, and the standard deviation is going to be equal to the original standard deviation divided by square root of n. Okay, what this means is, for example, if you had a class of 40 students and the mean exam score was 70, and then you said, okay, we're just going to pick a sample size of n equals 9, and you took every possible sample of size 9. Well, in some samples, the sample mean may be less than 70. In others, it may be greater than 70. But if you took all the samples, the mean of the samples, the mean of the sample means would equal the original mean. And the standard deviation would be the original standard deviation divided by square root of n. What this means is, if you look at the graphs, if this was the original data, the distribution of the original data, the sampling distribution would look something like this. In other words, there'd be less deviation because the standard deviation of the sampling distribution is going to be the original divided by square root of n. And remember, when you divide by square root of n, you're making the value smaller. When you divide by square root of n, you're making a number smaller. So the means will stay the same, but there's less deviation. The data is pulled towards the center in a certain sense. And in fact, that's where the name central limit theorem comes from. That's another topic that you'll cover. And this is just an introduction to that topic. So remember, the mean of the means is equal to the original mean, and the standard deviation of the means is the original standard deviation divided by square root of n. This is the key points to remember, okay? So this is an introduction to the sampling distribution, which is, in turn, something you're going to need for the central limit theorem. And these are the key points. The mean of the means is equal to the original mean, and the standard deviation of the sample means is the original standard deviation divided by square root of n. So those are the key points to remember.